For 1, 2, and 3, we're just looking at comparing the times of these 3 horses. It's asking us who has the greatest speed, which is the biggest number, the slowest speed, which is the smallest number, and then the 2 numbers that are the exact same. So if we look right off the bat, all of them have a 4 in the tens place, and all of them have a 7 in the ones place. So that doesn't help us, so we're just going to get rid of that so it doesn't confuse us. Then if we look, and I'm going to write it to the side, Fast Jack has 5/10, Gold Dust has 4/10, Firebrand has 6/10, and Relentless has 5/10. Well, we know from our studies in kindergarten that 6 is the biggest of those numbers, so Firebrand has the greatest speed. We know that the 4 is the smallest of all of them, so that has the slowest speed. Now, Fast Jack and Relentless look the same, but we want to make sure that we're not just looking at the tenths place. So I'm going to write Fast Jack's here, and I'm going to write Relentless here. Now remember, we can add as many zeros as we want after the decimal point. So when we do that, we have 0.510 and 0.510, so those two are the same. I'm not going to do very many of the bottom because most of these I know you know how to do. The biggest thing I need to remind you of is that you line up your decimal points, line up those place values. So I'm going to look at number 8. That is 5 minus 1.5. What we don't want to do is say, oh, this number looks bigger because it's 15 and write it. No, 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 no. The number is 5, and that's 5 ones, minus 1 1 and 5/10. The place values have to line up. Now, don't just subtract. We have to add a 0 here so that we can borrow. So now I'm going to borrow, and this is just like normal subtraction. You just happen to have a decimal point in the middle. This becomes 4, which now this becomes 10, and I subtract, and I have 3.5. Let's look at number 9 also. So I have 3.7. 3 ones, 7/10. I want to line up my other number exactly the same. I have 2 ones, 4/10, and 9/100. Just like in number 8, I want to add in this 0 to make it easier for me. And now I can go ahead and do my subtraction where I'm going to borrow. 10 minus 9 is 1. 6 minus 4 is 2. Bring my decimal point straight down. 3 minus 2 is 1, and there's your answer. Number 13 is one just like this, and as long as you remember our place values, you'll be just fine. 3 is the same thing as saying you have 3 ones. There are no ones in 5/1000ths, so I have 0 ones, and then I'm just going to write the rest of my number. And then I'm going to add zeros to after the decimal point. 3 by itself is the same thing as 3.00000 forever zeros. Now I can borrow, and I can't, oh my goodness, I have to keep going over here, which makes this 10/10, and then I borrow from there and make 10/100, and then I borrow from there and I get 10/1000, and then I subtract, and there's my answer. On the remembering side, 1 through 15 is just what we've been practicing since almost the first day of school. Just remember, parentheses come first, and remember if a number is right next to a variable, it's the same thing as saying multiply. I am going to look at number 8, where you have 7 equals h divided by 3. Because you know multiplication and division are in the same fact family, this is saying the same thing as if we multiply both sides by 3, because then this just makes it a 1, which means it cancels out, so you have h equals 21. Number 16 says Yoshi is making cards. He can choose from 4 colors of markers and 5 colors of paper. How many different ways can he create a card? Remember, when we're taking a certain number of one thing and then combining a certain number of something else. That is a combination problem. So we are combining 4 and 5, and we multiply those, and that gives us 20 different ways that he can create a card. Number 17 says, on the front of each card, Yoshi centers 3 rows with 6 stickers in each row. How many stickers does he use on the front of each card? Well, if I have, 3 rows going this way and 6 stickers in each thing, or you could say, okay, here's a row and I have 6 stickers, and here's a row and I have 6 stickers, and here's a row and I have 6 stickers. Repeated addition is the same thing as multiplication. My equation is 6 times 3 equals S for stickers, so you have 18 stickers. To make cards, Yoshi bought new markers. Each package he bought had 8 markers. He used 7 markers and had 25 markers left. How many packages of markers did he buy? So if I'm going to take these, I'm going to take these 2 numbers first because I want to know how many markers he started out with. So there were 25 left, plus he used 7 of them, which means if we're working backwards, he started with 32 markers. It's not asking how many markers he started with. It's asking how many packages he started with. So if he had 32 markers and they were divided into groups of 8, we just do that division problem, and then whatever your answer is, and I'll let you figure that out, you label as packages. Yoshi figured out that it costs him $2 for the supplies to make 1 card. So he decided to sell each card for $5. If he sells 6 cards, how much does Yoshi earn in profit? We can do this 2 different ways. We can either see how much he makes per card and then multiply it by 6, or we can see per package. That's the way I'm going to do it. So he makes $5. But he has to spend, which we subtract when we spend, he has to spend $2, which gives us $3 of money that he makes. It's asking us, though, how much money he makes on 6 cards, not just on 1. So I could say he makes $3 plus $3 plus $3 plus $3 plus $3 plus $3. A far easier way to do that is to say, oh, I have $3 times 6 cards for a total of, and then you're going to put your answer there.